All right, guys, we're going to talk through the entry 2 predicting product homework, which is on the bottom of the notes. So these are your blank notes here. The key is online. There's a video lecture. Hopefully you've watched that already. The primary and first thing that we need to do is work on identifying the reaction, because the type of products that I get are based off of the type of reaction that it is. So as an example, right here, I have an ionic compound, a metal and a nonmetal. Ionic compound, hydrogen's a +1 with a polyatomic. That tells me this is a double replacement reaction. Okay, so that determines the type of products that I'll make, or what happens in the products. Okay, I'm going to leave space to balance in all these. I'm just going to identify number 8, ionic compound, element, polyatomic, metal, polyatomic. Okay, this is another double replacement. Double replacements are the toughest ones to do, so we're going to start with those. And then I got a metal and a nonmetal, metal and a polyatomic, double replacement as well. Okay, so those are my 3 double replacement reactions. We're going to come back to the others. We're going to start with the most difficult one. So the first part, and this is the important piece here, is referencing your ions periodic table. This is on the main page of the Schoology. So sodium right here is a +1, and that's connected to chlorine, which is a -1. So I know the charge is both of those. And then I got hydrogen and carbonate. Hydrogen's a +1, and carbonate CO3 right here, the charge is listed -2. Okay, so sometimes it's helpful to just write the charges right above it. So +1, -1, +1, and -2. Okay, now for the sake of this, I'm going to not do that for every single problem that we do, but I'll do it for these as well. Beryllium, which is right here, is a +2, and then I think we had ClO4, which is chlorate, which is right here. That's a -1. Okay, and then so +2, -1. Since it's in parentheses, that whole thing stays together. Iron here, iron's charge. Remember, iron can be a 2 or 3. PO4 is always a -3. And iron can be a +2 or +3. Well, if it was a 3, they would cancel. Since I see this 2, that tells me that iron is a +2 here. That's the hardest part about these. Okay. And then both of these are 1s, so that's a 1, that's a 1. Silver's a 1. Nitrate is a -1 as well. Okay, so there's pluses and minuses here. I'm just saving time by doing that. Okay, so now what do I do with that information once I have the charges? If you're struggling to identify the charges when you're doing a single or double replacement reaction, okay, let me know, because that's oftentimes the most difficult piece. So now I have to work on writing the products on the other side. So the biggest thing is that sodium and hydrogen are going to switch what they're attached to. So this Cl is going to come over here. I'm going to do it this way. This Cl is going to come over here, and this carbonate is going to come over here. Okay, now I already know that that 2 is going over there with the Na, and the reason why is this. Okay, is that when they switch, remember sodium is going to be a I got to get back to my pen here. Sodium is going to be a +1 here. Okay. And carbonate from this side is going to be a -2. Now to crisscross those, the 2 goes down to this side right here, and the 1 goes there to the carbonate, so I still have 1 carbonate. H and Cl are both 1s, so those things cancel out, just giving me HCl. Now to balance, I would need a 2 here, and a 2 there. That gives me 2 H's, 2 H's, 2 NA's, 2 NA's, 2 CL's, 2 CL's. Remember, these blanks are 1. Okay. So again, that's the toughest part about these crisscrosses is how do I decide what the charges are? And once I'm able to do that, how can I go and put them on the other side? Okay. So now beryllium is going to go with phosphate. I'm just going to leave a little space here. Beryllium is going to go with phosphate, and PO4, and iron is going to go with perchlorate, which is over here. Okay, so I'm going to leave a little space for the crisscross here. Now, beryllium is a +2. Where are we at here? There we go. So this is really not the best way to do it, right? Beryllium's a 2, phosphate's a 3. Okay, that's from this side. That's what I just decided here. Notice the metal is always written first. Iron is a 2, perchlorate is a 1. Okay, so when I crisscross now, the idea is that the opposite charge ends up on the opposite element. So the 2 is going to end up on the PO4. So I'm going to just copy and paste a 2 over here. The 2 is going to go on a PO4. Okay. And the 3 from the phosphate is going to end up on beryllium. Okay. So that 3 went down here, that 2 went down there. Now the iron's charge, which was a 2, is going to end up on the perchlorate, and perchlorate's charge is going to end up on iron, and it's a 1, but I don't write 1s. Okay, so that's given me what my charges are. And now I can go ahead and balance. All right, so let's just start somewhere. Right here I got 3 irons. There I got 1. So I got to multiply by 3 out front here. Now I got 6 perchlorates. So over here I got to add a 3 to give me 6 perchlorates. 3 BEs, 3 BEs, 2 PO4s, 2 PO4s. Now I'm balanced. Okay. Now this one, the nice part is these are all 1s. So I just get to truly just copy and move these pieces from one side to the other. Okay, so now K is going to go with NO3. The 3 is part of the nitrate polyatomic ion, and I know that because if I were to look at my polyatomic ions list, I find nitrate right here. See how that 3 is down at the bottom? It's a subscript. It's a -1 charge. That tells me that 3 can't move anywhere. And then Ag is going to go with Br. Now they're all 1s, so that's balanced, and that's all it is. Okay, so that's probably the toughest one to balance. I'm not going to go through, to write products for. I'm not going to go through the thing for identifying charges. I'm going to talk through it, and if you have questions, please ask me. Okay, so in this, I should probably identify, The next ones I'm going to do are single replacement because that's a step down from the double replacement, but it's a little bit similar. Okay, so this is single replacement because I have a metal, calcium, an ionic compound there. 6 is also a single replacement, and I think number 12 right here is also a single replacement. Okay, so those are the next ones. Now, writing products there, all that happens, just like the double replacement, the metals switch spots. So Ca and Cu are going to switch spots. But I have to re-crisscross. So what I see is that calcium is a +2 on my thing. Chlorine is a -1. So when it crosses, the 1 goes to the calcium, the 2 goes to the chlorine, so I get a 2 there. So to balance it actually is what it is. Now, a common mistake is that it's like, okay, when do I put a 2 on this thing that's by itself? So would Cu get a 2 here? And the question is, and the answer is no, because there's sneaky 7. There's only 7 elements that get a 2 and they're by themselves. Okay, so I'm going to do the same thing here. Now, this one looks complicated because this polyatomic, Cr2O7, what I would recommend doing is finding it on my list. So dichromate's right here. Cr2O7, that 2 and that 7 can't change. And the charge of it is -2. Okay, so that 2 and that 7 have to stay there. So now Mg is going to go here, and Na is going to go there. So my question is, does a number go down here, and does a number go down here? Am I going to need parentheses? Well, magnesium is a +2, and dichromate is a -2, so they end up just canceling out. So it's MgCr2O7. Then to balance, I'm going to need to draw in some numbers here. And what I end up getting is I need 2 NAs. That's the only thing that needs to be balanced. So that's a 2 there, and that's it. Okay. I got one less single replacement. Now notice, and this will be the case for all of them, if I have a metal, so in this case nickel, let's see, need to arrow here. So if I have a metal, in this case nickel, which can form multiple charges, we're going to assume that it forms a +3. So I got a 2 and a 3 listed here. It's telling me that I'm going to use the 3. Okay. So that means iron's going to be by itself. Is it a sneaky 7? Nope. So it does not need a 2. And then I have to crisscross nickel with sulfate though. Okay, so this one, just preemptively, I'm going to put some parentheses here because I got to say how many I have. So when I draw, I need the charges. Now it's telling me that nickel is a 3 and sulfate from my list is a 2. If I go find sulfate, it's right here, SO4 with a -2 charge. The 4 has to stay, the 2 has to go there. That means the 2 is going to come down to the nickel. The 2 has to come down to the nickel. That is an @ sign. And the 3 has to go down to the sulfate. And then now I get to balance. Okay, so to balance, I need 2 nickels. Because I got 2 there. I got 3 sulfates, so I need a 3 there. That gives me 3 irons. Sorry, that should be a 3 and 1 there. So I'm just going to rewrite that because that was trash. 3, 1. And that's how I balance. Now, I'm going to go ahead and move on to my next type, which is synthesis. So synthesis, or I have and the only time we'll see synthesis in our unit is when I have a metal and a non-metal, and I have to crisscross those, so that's why I'm choosing synthesis next. Metal and a non-metal, synthesis, have to put those together. Okay, so I have to crisscross charges. Now notice when I have my reactants, Li does not have a 2, O has a 2, and that's because Li is not a sneaky 7, okay, but O is. Okay, so when I'm writing my products, what I have to do is figure out the charges of these things and then crisscross them. Okay, so that's really what I'm focused on here. So for my periodic table, lithium is a +1, O is a 2. So that means the 2, or the 1 from the lithium, is getting up on O. Don't got to worry about that. And the 2 from the oxygen is going to end up on the lithium. Now, notice here it's a subscript, not a charge. So when I'm crisscrossing, the charges are written up top and they come down to write subscripts. Okay. So that's what I get for that synthesis reaction. This one, very much similar. Yeah, I know initially it's going to be like, all right, I got to put my products together into one compound. That's synthesis. K and I are both 1s. So it's just going to be a 1 and a 1. They cancel, so I just get Ki. That means to balance, I need to put a 2 there to give me 2 I's and a 2 there. Okay. And for this one, to balance, I need to put a 2 there to double my oxygens, which is going to give me a 4 there for lithium. Now, the last two, combustion and combustion, is a carbon compound and oxygen. The nice part about these is the products are always carbon dioxide and water. So give me a second. I'm going to pause because my video is getting close to the end here and writing that in. Carbon compound and oxygen produce CO2 and H2O, and now I just have to balance. So when I balance, remember I have oxygen in 2 spots on this right side, on my product side, so I'm going to do that last. So I'm going to start with my C's, 5, start with my H's, 6, then add up my O's. I got 10 and 6 for a total of 16, so I need 8 oxygens here. And then lastly down here, I got 1 carbon, 4 oxygens, hydrogens, so I need 4 hydrogens. That gives me 2, 4 oxygens, so I need 2 there. And then the last type of reaction I have is my decomposition, where I have 1 reactant. And the first thing you want to do is split it up into the elements. So again, I'm going to pause the video and put those products in just for sake of time. So give me 2 seconds. Position, I have 1 reactant. All I do is split it into my elements. Then I got to decide, does BA need a subscript 2 when it's by itself? So I'm asking, is it a sneaky 7? The answer is no, so it is not. Is oxygen? Yes, so oxygen needs a 2. Okay. And then same thing down here with number 9. Does sodium need a 2? Is it a sneaky 7? No. Is chlorine? Yep. So I need a 2. And then I can go back and balance these, which are just using 2s. And I get a 2 there to balance my CLs, and then a 2 there to balance my NAs, a 2 there to balance my O's, and a 2 there to balance my BAs. Please ask questions. This is a tough one for a lot of people, so let me know. Thanks. Bye.